So this video is going to be a quick overview of how to use a shortcut to factor your perfect square trinomials. So I'm going to start by just showing you another example of regular factoring. So in this quadratic, we have y equals 2x squared plus 15x minus 8. And I'm going to use grouping with the box method to show you how you would find the two binomials that were multiplied together in the first place to create this problem. So this is kind of an overview of last week. So to start with, I would go ahead in my box and place 2x squared and negative 8. Then I need to find that product of those two values. So 2x squared times negative 8 would be negative 16x squared. That means that the product of the other two factors or the other two terms in this would need to be also negative 16x squared. So if I think of negative 16x squared, I could think of factors of that value. So we could have 16x and negative 1x. We could have 8x and negative 2x. We could have 4x and negative 4x. And then I could also have negative 16x, positive 1x, negative 8x, and positive 2x. But I know that those would create a negative sum, and I need a positive sum to make positive 15x here in the middle. So if I think about what these have a combined value of as far as like terms, then we have 15x, 6x, and 0x. So our middle term is 15x, which would be that first choice. So these are the two factors that I would want to use so that my middle term is 15x. Okay, so here I will put negative 1x and 16x here. Remember, it does not matter which one you put where. Now, some of you asked me questions about what does grouping mean, and I guess I didn't do a great job of making sure you understood that we are talking about a group of terms. So this first row represents a group of terms. It's a grouping. This second row also represents a group of terms, so it's a grouping. If you were using reverse distribution, which I'll show you that one in just a second, it's still grouping. You're still grouping those two together, but with reverse distribution, we typically put them in parentheses, which is kind of why we call it grouping. So what I want to do now is find the greatest common factor of those groups. So between 2x squared and negative 1x, the greatest common factor is x. Because 2 and negative 1 don't have anything in common except 1. And then between 16x and negative 8, the greatest common factor there would be 8. Now, you can also find the greatest common factor of your columns, but I actually think it's easier just to figure out what they would have multiplied by to make those boxes. So if I have x, then what do I need to multiply x by to get 2x squared? That would be 2x. And then I can check and say, well, does 2x times 8 make 16x? And it does. So then I would say, well, what times x would give me negative 1x? And that would be negative 1. So negative 1 times x is negative 1x here, and negative 1 times 8 is negative 8 here. So that would create this trinomial. So the factored form, if we wrote it as two binomial groups, would be x plus 8 times 2x minus 1. Now, since a ton of you were using reverse distribution on this last week on the assignment, I will go ahead and show you the reverse distribution. It is exactly the same thing. It's just that organization. When we talked about multiplying binomials, remember we did distribution and then we did the box method. They're the same thing. It's just the way that it's organized. So if I have 2x squared and negative 8, I still need to find the product of those two values, which is still negative 16x squared. And then I would still need to find two terms that 15x can be split into that have the same product as 2x squared and negative 8. So that's that negative 16x squared. That's where we would come up with this 16x and negative x. So if I put in negative 1x plus 16x, and then the minus 8. Then I'm going to create groupings. So I'm going to group the first two terms, which matches my first row, and I'm going to group the second two terms, which matches the second row of my box. So it's really the same process. Out of each group, I would factor out the greatest common factor. So between 2x squared and negative 1x, the greatest common factor is x. So I would have x times 2x minus 1. And then between 16x and 8, the greatest common factor is 8. So plus 8 times 2x minus 1. Then you have these two binomials that are both being multiplied by single terms. Since they're both being multiplied by the same, since x and 8 are both being multiplied by 2x minus 1, we can go ahead and say that x and 8 are going to multiply by 2x minus 1. So these outside terms become a binomial, and then the binomial that we already have becomes this other binomial. And that's still the factored form. So it's really the same thing. If you feel more confident using that reverse distribution method, feel free. So before we get into the perfect squares, I want to just take a quick minute to review how to square these binomials anyways. If we used our box method to multiply these out, then we would have 3x plus 8 times 3x plus 8. So that would create 9x squared, 24x, 24x, and 64. And remember when we talked about this in class that we talked about that these two diagonals, when we're talking about perfect squares, should always match. So it should be two of the same value, two of the same things. So when we go to write our final form, we would have y equals 9x squared plus 48x plus 64. And then with the subtraction one, it would still be the same thing. So we would have 2x minus 5, 2x minus 5. That would create 2x times 2x would be 4x squared. 2x times negative 5 would be negative 10x. Negative 5 times 2x would be negative 10x again. And then negative 5 times negative 5 would be a positive 25. So you can see on this one, again, that these two boxes are identical. So it wouldn't matter if we have a binomial that's adding or a binomial that is subtracting. That middle term should still be twice itself. So 4x squared minus 20x plus 25. And then we talked about, well, what we're really doing is squaring the first term and the second term in the binomial. So 3x squared gives us 9x squared, and 8 squared gives us 64. To get the middle term, if you remember, we said that we multiplied them together twice. So we would say it was 2 times 3x times 8. And that's where we were getting 48x from. On this one, we would have done 2 times 2x times negative 5, which is where we're getting negative 20x from. So that leads us into how can we use that idea to factor if we already have the trinomial form. So the first thing you would want to look for when you're looking is for patterns. So we want to see, do we have some number squared at the front and back of the trinomial? So the first and third term should be perfect squares. And then the middle term should be those values together twice. So that's the two things you're going to look for. There's going to be two tests you're looking to pass here. Are the first and third terms perfect squares? If the answer to that is no, then you can't use this shortcut. You would just need to factor it normally. If it is yes, then you would go on to say, is the middle term twice the product of a and b? Now, when you're looking at the trinomial, you don't even have a and b. You have a squared and b squared, so we would need to get a and b and then check that middle term. So let's look through an example. Here is the trinomial 4x squared plus 28x plus 49. So our first test is, are the first two terms perfect squares? So we have 4x squared and 49. Are those perfect squares? And the answer to that is yes. 4 is a perfect square and x squared is a perfect square. So that one is something times itself, or could be written as something times itself. And then 49 is also possibly written as something times itself. So then we would move on to the second test because we passed this one. The second test says, is the middle term twice the product of A and B? So we need to find A and B. So remember that these represent A squared and B squared if it is a perfect square trinomial. So we would need to find the square root of 4x squared to figure out what was multiplied by itself. The square root of 4x squared would be 2x. So that's going to be our A value. Our B value would be the square root of 49, which is 7. And then we would check, is the middle term twice A times B? So is it 2 times 2x times 7? And that would be 28x, which matches our middle term. So we do have a perfect square trinomial. That means we can write it as a square of the binomial A and B. And if this middle term is addition, then your binomial is addition. If it's subtraction, then your binomial is subtraction. So our factored form here would be 2x, because that's our A value, plus 7, because that's our B value, and the whole thing would be squared. Now, do you have to use this shortcut for these? No. You could still go ahead and factor it using the reverse distribution or using the box method to create those groupings so that you can find those two binomials. But when you do that, you're going to get 2x plus 7 and 2x plus 7. And you should recognize then that it's something times itself. So it would be written squared. So this would be our form. So now we're going to check this one to see if it's a perfect square trinomial. So first we're going to look at, are the first and third terms perfect square? Well, 4x squared is a perfect square. 8 is not a perfect square. There's nothing times itself that would be an integer value that's going to make 8. And so at that point, there's no reason to move forward with this. It's not a perfect square. So we would have to go ahead and factor this one using either that box method for grouping or the reverse distribution for grouping. Now, before I move into actually going ahead and factoring this out, I want to check, do these terms have something in common, a greatest common factor already? And if they do, I want to remove that first. So between 4x squared, negative 18x, and positive 8, they do have a common factor of 2. So I want to factor out a 2 so that this trinomial is as simplified as it can be. Otherwise, I could get one of two different answers, which makes it a little more challenging when I'm trying to complete an assignment. You may have seen that happen last week with one of the questions. So once I factor out the 2, I have 2x squared minus 9x plus 4, and that will be what I can factor now. So 2x squared and positive 4. That gives me a product of 8x squared. So 8x squared, what are some factors of 8x squared that would create a negative 9x? So to get a positive, I either need two positives or I need two negatives. If I do 8x times 1x, that would give me positive 9x when I combine those like terms. But I need a negative 9x. So if I did negative 8x and negative 1x, that would give me negative 9x. So that would be the terms I need to break negative 9x into. So I'm going to do negative 8x and negative 1x. So now I'll go ahead and factor. I want to find the greatest common factor between those groups on the first row and that group on the second row. So on the first row, between 2x squared and negative 8x, their greatest common factor is 2x. And then between negative 1x and positive 4, their greatest common factor would be 1. However, since I need to get a negative in here somewhere, and I know that I need to use two negatives to make this positive 4 because of these middle terms being negative, I'm actually going to pull out a negative 1. I typically would not pull out a negative if one is positive and one is negative, except in this scenario where ax squared and c are positive, but b is negative. It's the only time I would pull a negative, when one is negative and one is positive. So that's going to be 2x minus 1. On To make it work, 2x times x would make 2x squared, and x times -1 would make -1x. Now here, if I had done +1, this wouldn't work. And so if I made it -x, it wouldn't work for 2x squared. So that's kind of where I would know, like, oh, I need to make something negative, and it would be that -1. We wouldn't want to make x negative when we could make the constant negative. So on the second column, 2x times -4 would make -8x. And then -4 times -1 would make +4. So that would work for this box. So our factored form here would be y equals 2x minus 1 times x minus 4. Okay, let's try one more and see if it's a perfect square trinomial. So we're going to look at the first term and see, is it a perfect square? Is x squared represented by something times itself? Yes, it's represented by x times x. And then is 16 a perfect square? Yes, it can be represented by 4 times 4. So I would find the a and b value, which means I'm looking for what times itself gave me those. So for a, I would take the square root of x squared, which is x. So x times x was x squared. That means our a value was x. And then for b, I would do the square root of 16, which is 4. And now I want to check, does my middle term work as a product of those two? And so 2 times x times 4 would actually be positive 8x, but a negative times a negative would also give me a positive. So if I called this a -4, -4 times -4 is still 16. And if this was negative, now it would be a -8x. So yes, this will work for a perfect square trinomial. It really doesn't matter if that middle term is positive or negative. Since it is negative, when we write this, as it would be a minus b instead of a plus b. So we would do a minus b squared. And for us, that would be x minus 4 squared. So that would be our factored form. Now, if you're super confused on this shortcut, remember you don't have to use it. So let's say that you don't want to use it at all. Then we could factor normally. If I use the box method, they don't have anything in common to factor out first. So x squared and 16. And then I would just need to find factors of 16x squared that create -8x in the middle. That's going to be -4x and -4x. If you ever end up putting the same thing in both of those two diagonals, that means you're looking at a perfect square trinomial. So when we go to factor out, between x squared and -4x, the only thing in common is x. And between -4x and 16, I'm going to pull out a -4 because I have to get that negative in the middle and the last term is positive. So up here, to make it work, x times x is x squared, x times -4 is 4x. X times -4 is -4x, and -4 times -4 is 16. So you see how we're getting the exact same thing on both sides? That's because it's this perfect square. So either way, you would still get x minus 4 squared times itself. So that's the shortcut for perfect square trinomials. If you don't feel confident using the shortcut, please just make sure you factor it.